to talk about urinary system. So, and today we'll talk about the kidney. Yes, about the role of kidney, I think you know, and so the urinary system, what's the main function of the urinary system? This is the urinary system monitors the blood, yes, the components of the blood. And these are the functions of the kidney, and I want to start to talk about the histology, yes, the morphology of the kidney. So the kidney is covered by the connective tissue capsule. Yes, this is the connective tissue capsule, you can see, and has two parts. The cortex, the outer part is the cortex, the inner part is the medulla. And this part, this is the hilum. So what's the hilum? This is the region where enters and exits blood vessels, you know, lymph vessels also, and where you can see the part of this ureter. Yes, and this ureter then divides and forms renal pelvis. This is the renal pelvis region. Then are the 2 or 3 major calyxes, and then are minor calyxes. So renal pelvis, major calyxes, and then are minor calyxes. And then so also you can see adipose tissue, yes, around the calyxes and around the renal pelvis is always adipose tissue. Then starts pyramids. How many pyramids? 8 to 12. Yes, 8 to 12 pyramids are located into the renal medulla. You can see this part is the renal medulla, renal pyramids, and projections and extensions from the cortex to the between the pyramids are here the medullary rays. Yes, this is the medullary rays, and this part, the pyramid, with parts of the cortex forms lobe. I want to show it, yes, here. So these are the pyramids, 8 to 12 pyramids. Then medullary rays, yes, the medullary rays, and the renal columns. So again, cortex and medulla, renal pelvis, major calyxes, minor calyxes, then pyramids. Yes, the pyramids, and so the projections from the pyramids forms the medullary rays, and the cortex forms the renal columns. And pyramid with medullary rays, so with the parts of the cortex forms the renal lobes, and between the pyramids, this part, this tubular here, the tubular, the parts here, this part with the cortex forms the renal lobes and renal lobules here. Okay, so here this is the tissue, yes, of course, the kidney, this part is the cortex, and this part is medulla, yes, the medulla. You can see this is the cortex. Why this is the cortex? I said during the lecture, so because we can see here the numerous glomerulus. Numerous glomerulus are located into the cortex. Yes. Okay. The here. So pyramid with part of the cortex. Yes, with part of the cortex. This is the renal lobe, and this part forms the renal lobule. more shorter part. Okay, so this is here you can see the cortex with the glomerulus, and these are the tubular structures from the medulla. And now this part. So what is the structural unit of the kidney? Nephron. Yes, the nephron, and millions of nephrons are located in each kidney. And if more older individuals, less than 1 million, of course. And the nephron, this is the difficult structure because it has different parts. What's this? It's the corpuscle, renal corpuscle, something like the head of the nephron, and then starts the tubular structures. Yes, tubular structures. Which parts have the nephrons? Starting, I want to show this. So this is the renal corpuscle. Yes, the renal corpuscle is here, and renal corpuscles always are located into the cortex. Then starts tubular structures. Yes, tubular structures. So all these structures together form the nephrons. The first, this is the distal convoluted tubule. Distal convoluted tubule. Then next is starts the loop of Henle, yes, proximal straight tubule. Then is thin descending limb, then is the thin ascending limb, then is the straight, the more thick ascending tubule, and then this is the distal convoluted tubule. From this then starts connecting tubules, short connecting tubules, and the next is the collecting ducts. About collecting ducts, we'll talk in next week. And now I want to show this part. This is the renal corpuscle. Yes, the renal corpuscle. What's the renal corpuscle? It's the capsule. And into this renal corpuscle are capillaries, fenestrated capillary stuffed, this glomerulus. Yes, glomerulus, this is the glomerulus. What's the glomerulus? This is the capillary stuffed glomerulus. And around these capillaries is the capsule with two walls. Yes, the visceral and the parietal layers has this capsule, Bowman's capsule, yes. So the visceral layer, really, this is the layer with very interesting cells. These cells are the podocytes, and this, yes. And the outer layer, which is the surface layer, parietal layer, this is the covering layer, and here are located flat cells, squamous cells. Yes, the squamous cells are. Okay, so about podocytes we'll talk also, but I want to show two poles of these renal corpuscles. These are the visceral pole, and these are the poles, the vascular pole where starts and blood vessels, yes, and this is tubular pole where starts the proximal convoluted tubule. So the proximal convoluted tubule starts the opposite of this pole, where is the vascular pole. So visceral layer, parietal layer forms the capsule, and the two poles are proximal. Here the proximal convoluted tubule where starts the tubular pole, and this is the vascular pole where are located the afferent and efferent arterioles. Okay, so this, yes, this is the glomerulus here and the Bowman's capsule with two layers, and between these layers is the Bowman's space. So the very important part is this, because here proceeds filtration. Here proceeds filtration, and so the parts of this filtration apparatus, three parts are here. We'll start from this. Okay, this is more interesting. Three parts: endothelial cells. So the fenestrated endothelial cells, fenestrated capillaries are here. Then this part, the podocytes, forms this part, and the basement membrane. Yes, very big basement membrane is here. So this basement membrane is formed by two these different cells. Yes, from the endothelial cells and the these podocytes, the both form this basement, very thick basement membrane, 300, approximately 300 nanometer. Oh, endothelial cells you can see, and the fenestrations also are visible here. Now, what about the podocytes? Yes, the podocytes, they are very large, very specific cells, and they have processes, the primary and the secondary processes. Infiltration apparatus are involved secondary processes, and they have names. Yes, the specific name they have, the name of these processes, they are pedicels. And the pedicels, and between these pedicels, you can see here are also the slits covered by very thin diaphragm. And in this diaphragm also are openings. And so the endothelial, yes, the fenestration of the endothelial cells, basement membrane, and the slits, yes, slits with diaphragm, but in this diaphragm, I said, are openings. And these three components together form filtration apparatus, and the endothelial cells, they block blood vessels, diaphragm blocks the more large proteins, and the membrane blocks more large proteins, and the slits filtration slits diaphragm, it blocks the more small proteins. So podocytes, we know, yes, they are cells, and these cells are located into the visceral wall of the capsule. And here, in between these cells, also are located another type of cells, mesangial cells. So mesangial cells, which usually is more difficult. Yes, with simple preparations, histological preparations, it's very difficult to find these cells. And so what are the functions of these mesangial cells? The function, physical support, is the function of these cells, so physical support of capillaries within the glomerulus, of course, also contractions, then phagocytosis. Also, they secrete several cytokines, so they also are very important cells, mesangial cells. Here you can see the glomerulus. Yes, this is the glomerulus. It's the Bowman's capsule, and this layer is the parietal layer with squamous cells. And of course, it's difficult to find podocytes because these cells are located on the surface of the capillaries. Yes, and between these are also mesangial cells. But we can see space between these layers. This is space, Bowman space. here. Okay, so about renal the corpuscle, so we know this is very important part of the nephron where proceeds filtration. Yes, then now about tubules, proximal, distal tubules, and loop of Henle. Yes, starting from the proximal convoluted tubules. So the surface layer, which is the parietal layer. Yes, here are squamous cells located, but then these cells, they lead to the another type of cells of cuboidal cells, and then starts the proximal convoluted tubule. So the proximal convoluted tubule, here are cuboidal cells, and you know, very active cells. Why? Because these cells have the both function. Here proceeds reabsorption and also proceeds secretion. And yes, the proximal convoluted tubules, in which pole they are located? In tubular pole. Yes, in tubular pole they are located, proximal convoluted tubules. So what proceeds here? Here proceeds reabsorption. Yes, the over half of water and electrolytes, also organic nutrients, absorption proceeds in proximal convoluted tubules, and the both type of mechanisms, active, passive mechanisms, are involved in this reabsorption. Also, this is the one function of these cells. Reabsorption proceeds, and also proceeds secretion. Yes, the secretion, here proceeds secretion of organic ions and cations, not filtered in the renal corpuscle, and they may be released in the peritubular capillaries, secretion into the then filtrate. So, proximal convoluted tubule. This is, yes, the high magnification of cell of the proximal convoluted tubules, and the very large round nuclei they have, and very acidophilic these cells are. Why these cells are so acidophilic? Because here are numerous mitochondria. Yes, the numerous specific mitochondria, and if you remember, these mitochondria are located between invagginations. Yes, the basal invagginations here. And the opposite of the basal, on the apical part, are numerous microvilli, and therefore brush border. Where we also have brush border in small intestine. Yes, in small intestine brush border. Here also is brush border with numerous microvilli. And what's the function of this microvilli? Absorption. And you can see here the vesicles and lysosomes also. So these cells are very active cells. Then, yes, so if we compare the cells of the proximal convoluted tubules and distal convoluted tubules, because these cells are both cuboidal, yes, cells, you can see these cells are more rich in mitochondria, and also numerous microvilli on the apical surface. And distal convoluted tubule cells, they also are cuboidal cells, a few microvilli they also have mitochondria, but not so many mitochondria are here. So they are less active cells compared to the proximal convoluted tubule cells. So what proceeds here? Here also proceeds reabsorption, but here proceeds reabsorption of electrolytes. Yes, electrolytes, reabsorption. So here reabsorption, secretion, more processes proceeds in proximal convoluted tubules. Now about loop of Henle. Yes, loop of Henle. So loop of Henle. Here are thin tubules. If distal and proximal convoluted tubules, we have cuboidal cells. Here in loop of Henle are more flat cells. So like these, yes, these loop of Henle, these here, these cells are squamous cells. Thin descending, thin ascending. So now what proceeds into the loop of Henle? In descending limb proceeds water withdrawal passively, and into the thin ascending limb proceeds reabsorption, sodium chloride, but this part is impermeable to water. So please remember, yes, this part, so impermeable to water is the thin ascending limb loop of Henle. And important part also here, I want to go back and show thick ascending part. So which part is this? I'm going back now, sorry. Not this. Here. This thick distal stride part. So this is the thick ascending limb. Yes, thick ascending limb. Here also are cuboidal cells, but no microvilli. Also are mitochondria here. And so what proceeds here? Here proceeds also reabsorption. Here proceeds reabsorption, actively transport sodium and chloride ions. So this part, thick ascending limb, also is involved in reabsorption of sodium and chloride ions. And what also we have to know, yes, of course, the blood supply, which is very interesting in kidneys, and different arteries are here, and the names of these arteries is associated with their location, and parallel of these arteries are located also veins. Yes, enters here the renal artery, of course exit the renal vein, and the branches of the renal arteries are in segmental arteries. Then next branches are interlobal arteries, and the next segments are arcuate arteries. And if you remember, the arcuate arteries, they are located between the cortex and medulla, and to guess that this is the arcuate artery is more easy because visible is this part, yes, transitional zone between the cortex and medulla, arcuate arteries. Then from the arcuate artery starts interlobular arteries. Now blood supply, glomerulus. Yes, so into the glomerulus enters afferent arteriole. Then is capillaries network, of course. This capillaries network, capillary shaft, which form the glomerulus. Then exit, not venule, but again arterial, efferent arterial. Yes, efferent arterial. And the efferent arterial then forms another capillaries network. This is the peritubular capillaries, and this part, this network, also is located into the cortex. So what we have here? We have here the portal system, if you remember. Yes, there are three different pathways: simple pathway, arterioventricular short, and also is the portal system. This is portal system. So two capillaries networks, and between capillaries networks is located another blood vessel, maybe venule, maybe arterial. In kidneys is arterial. And now what's the vasa recta? Vasa recta also is the capillaries, network, so the capillary part, but so the small blood vessels. Nephrons, the nephrons glomerulus, are located always in cortex, yes, but between nephrons are juxtaglomerular nephrons, and these nephrons, the corpuscles of these nephrons, are located near the medulla. So 1/7 of all number of nephrons are juxtaglomerular nephrons, and these nephrons, efferent arterioles, forms vasa recta, which is associated with loop of Henle. Okay, and what I also want to remind you, yes, and the last part, this is juxtaglomerular apparatus. Yes, the juxtaglomerular apparatus. Now I'm going, then I'll show micrographs. Juxtaglomerular apparatus. So this part. So this is glomerulus, of course, urinary space, then is the capsule here. Also, we can see here the afferent arteriole. So this is vascular pole. Yes, vascular pole. Then so which parts, so which components are involved in juxtaglomerular apparatus? Juxtaglomerular, if you remember the thick ascending part, loop of Henle, so the cuboidal cells, they are changed, and these cuboidal cells become more columnar, more closer located to each other, and they form macula densa. This is macula densa. Also, the cells of afferent arteriole, these cells also are modified here, and arterioles, yes, the inner cells are endothelial cells, squamous cells, and arterioles have 2-3 layers of smooth muscle cells. And smooth muscle cells layer is changed here, and smooth muscle cells, the function of these cells is contraction, yes, but here these smooth muscle cells become another type of cells. They become secretory cells, and they start secretion of renin, and they contain zymogen granules into the apical part of these cells. So modified cells, cuboidal cells, and modified smooth muscle cells, macula densa and juxtaglomerular cells. Macula densa, this part, and juxtaglomerular cells, they are modified smooth muscle cells of afferent arterioles. And together they form juxtaglomerular apparatus. So now what is the function of this? What's the function of this apparatus? Monitoring blood pressure. Yes, the monitoring blood pressure. And how proceeds this process? How the proceeds? What are the steps? They elevated arterial pressure increases glomerular capillary blood pressure, and which increases the glomerular filtration rate. Increased glomerular filtration rate increases, of course, and concentration, sodium, chloride ions, and increases so its influence on macula densa cells, which these cells are sensitive to sodium ion concentration, and proceeds contraction macula densa cells. So then proceeds its influence on the afferent arterioles, proceeds contraction of afferent arterioles, and which lowers glomerular pressure and decreases the glomerular filtration rate. And lower tubular ion concentration turns off the release of vasoconstrictions from the macula densa, and decreased arterial pressure lead to influence on the baroreceptors of and the baroreceptors afferent arterioles, and starts renin secretion. And then what proceeds? Proceeds after the renin secretion, proceeds these processes. Conversion angiotensinogen into the angiotensin 1, then angiotensin 2, and these especially the angiotensin 2, this vasoconstrictor rises systemic blood pressure and stimulates the adrenal glands and starts secretion aldosterone. Yes, aldosterone secretion, and the aldosterone secretion promotes sodium and water reabsorption in the distal convoluted then tubules, and it raises blood volume, and it leads to the increased blood pressure, and the increased blood pressure switch of renin secretion. So this is the mechanism. Yes, starting from the elevated pressure, which increases the glomerular filtration rate. Glomerular filtration rate then influence on the macula densa cells, then influence on the baroreceptors, then baroreceptors influence to formation angiotensin from the angiotensinogen angiotensin, then at first the renin secretion, then proceeds the formation from angiotensinogen, angiotensin 1, angiotensin 2, then its influence on adrenal glands, influence on secretion aldosterone, then proceeds the sodium water reabsorption, and this leads to the increase in the blood pressure, and then proceeds switch off renin secretion. I think it's understandable. If not, you can ask me about this. Then these are they are collecting ducts, and about collecting ducts, I said we'll talk more later. Now I want to show some micrographs. At first, if you have any questions, you can ask me. Have you any questions? If something is not understandable? Okay, if everything is understandable, I want to show some micrographs from Histology guide, of course. Okay, so this is, yes, tissue of kidney. So this is the cortex, and this part is medulla. Yes, cortex and medulla. And in cortex, renal corpuscles, numerous renal corpuscles are here. Then medullary rays, yes, medullary rays, tubular system we can see here. Then medulla, and the renal pelvis here. Now I want to show the arcuate arteries. Yes, arcuate arteries. I don't know why it's, yes, here, more visible. Yes, they are located, the arcuate arteries, between the cortex region and medulla. Arcuate arteries between cortex and medulla. Okay, another. Yes, Bowman's capsule. So what's Bowman capsule? Bowman capsule is the covering capsule with the, which covers glomerulus. Yes, this is the glomerulus. Capillaries are here. It's the capsule, Bowman's capsule, and this is Bowman's space here. These parietal layers, squamous cells, you can see elongated nuclear of the cells, and visceral layer is formed by the cells, the podocytes, and also are mesenterial cells, as here. And juxtaglomerular, yes, apparatus, juxtaglomerulus apparatus near the vascular pole. And urinary pole, I want to show urinary pole. Yes, this. Sorry. This part. Urinary pole. And opposite of this, vascular pole. And proximal convoluted tubule. And we can compare the proximal and distal convoluted tubules. Proximal convoluted tubules have more narrow lumen, and this lumen is filled something with some substances. And distal convoluted tubules, they have more empty lumen. Yes, more empty lumen. For example, more empty lumen they have, distal convoluted tubules, compared to the proximal convoluted tubules. Now, distal straight tubule, but this is longitudinal section. So what distal straight tubule, this is the from thin tubules of the loop of Henle start thick ascending, the distal straight tubule, which runs back again to the cortex. Yes, and then this is near the glomerulus, and from these cells, cuboidal cells, then forms macula densa. Now, what's macula densa? This part, yes, the macula densa. So more closer, more harder part of these tubules is macula densa. Function, contraction, yes, macula densa. But also are another cells, yes, juxtaglomerular cells. I don't know, can we find? No, not juxtaglomerular cells are here. Again, another. Macula densa, distal, no. Okay, again, macular densa we can see, and the more difficult is to find. Yes, the cells, juxtaglomerular cells, but they are modified smooth muscle cells of afferent arterioles, renin secreting cells, and contain numerous zymogen, the granules contain. So this part, yes, this part is here, and this is the vascular pole and tubular pole. Yes, this is the proximal convoluted tubules, proximal convoluted tubules. You can see so close is the lumen in these tubules. And I only want to show the collecting ducts, but more detail we'll talk about these ducts later. In next week, of course, the collecting ducts, and collecting ducts, the individual cells are more easy visible because the boundaries are more clearly seen between the cells compared to the distal and the proximal convoluted tubules. Okay, now I have the question, do you want a break or not? Or we can continue? Yes, okay. If yes, 10 minutes, then we'll continue. 10 minutes. And you can also compare some questions. If something is not understandable, you can send me questions. Yes, after the break, 10 minutes break.